Yeah, hi Sanjay. Am I audible?
Yeah, hi Nitish. Hi everyone.
Wonderful. All right. So first and foremost, very warm welcome to everyone for taking your time out and joining today's webinar. And as with all our webinars, this is also part of our series deep dive with IIQF expert series of webinars, which we conduct once or twice every month on important topics related to finance, risk management, quant, algo trading, machine learning, data science, and applications in finance. Right. So, briefly, very quickly, first to introduce the speaker. Uh, the speaker for today's session would be Sanjay Bhatia, and Sanjay has done his MBA Finance and MSc in Machine Learning and AI from Liverpool John Moores University, and he also has a PG diploma in Machine Learning and AI from Triple IT Bangalore. Sanjay is actually a risk management and analytics professional with more than 16 plus years of mainstay experience in risk modeling methodology space, encompassing Basel, AIRB, IFRS 9, IMM, SSECR exposure, XBA, FRTB, OTC derivative pricing, and other specific modeling topics. He has previously worked with various foreign banks, Barclays, RBS, Credit Suisse, UBS, Citibank, and in all of this primarily in the risk and management and risk consulting domain. Sanjay is a very passionate educator as well, so he loves to impart education, practical model understanding and impart understanding and insights through his trainings, and has been a professional trainer for corporate and investment banks. His main area of interest in terms of academics or teaching is like in credit and counterparty credit risk, market risk, stress testing, stochastic modeling, quantitative finance, and of course machine learning, which he currently works more. Right. So for before I hand over the session to Sanjay, very quickly, I'll just give a brief laydown. As you all know, the session would be for a period of about 1 hour and followed by a Q&A. So during the session, post session, or now also, if you have any particular questions that you want to ask in realm of today's discussion, please feel free to type in your questions in the chat window. We would love the session to be interactive to keep the questions flowing, right? Yes, of course. Since the participation is quite large, so unfortunately, we'll not be able to allow everyone to speak up. But nonetheless, you can always maybe you can always type in your question in the chat window. So yeah, let's make the session as interactive as possible. And yeah, in the meantime, let me make Sanjay the presenter so that Sanjay can start the presentation. Just give me a moment. Yes, Sanjay. So I'm made you the presenter. Whenever you're ready, please feel free to start.
Sure, Nitish. I hope my screen is visible. I hope my screen is visible. Am I audible, Nitish? You are.
Yes. So we can see your screen, but yeah, we are not able to see you though. But yeah, the screen is visible.
Okay, let me maybe turn on my camera. Uh, I think it's throwing some error that I need to give access to my camera. Just give me a minute. Nitish, you have to make me presenter again. I think you're still on mute.
Yeah, just allow us 1 minute. I mean, just we'll Sanjay is trying to re-log in.
Before any, just to avoid any further delay, so let's quickly maybe just jump on to the topic of interest which we have set up for today. The topic basically is career in risk modeling, career in risk modeling using AI, uh, and maybe with regards to that, what are different career pathways, what are different career skills, and what should be a career trajectory and career progression strategy, right? How one should plan their career given that the entire risk modeling and risk quants and risk management space is very much disrupted. So within that, how we are going to go about? First of all, I'll give you a flavor of what a quantitative risk modeling landscape look like, right? Then we would be talking about some of the emerging, evolving trends within risk management and risk modeling and quantitative risk, uh, you know, uh, forecasting or modeling, right? And then we would be pretty much settled with that. Okay, the landscape of risk management and risk modeling is this, and within that, maybe we have different components, how they are evolving or emerging with the disruption from AI and ML and data science. Uh, and then we would be talking about maybe from a risk practitioner perspective, from a risk management professional perspective, who is a seasoned professional who has been working in risk management, how to plan your career, right? What are the career pathways for you available? What those career pathways, how they map up to the core skills and core competencies which are required and desired and in demand from industry, specifically the fintech disruptors, the fintech firms, as well as the many of the uh, big Wall Street banks and financial institutions which are following the suit of fintech in order to evolve their uh, business model as well, to be more agile and to be better at go to market strategy, right? So since maybe the entire industry is converging from a pure brick and mortar banking firm to a more agile, maybe tech driven fintech firm, the roles are drastically changing, and that is the tectonic shift. And that tectonic shift, which is owing to the change in the business model and rebooting of the business model to make it more tech driven, than maybe in a brick and mortar kind of bank, how it was more a manual process or maybe people driven. Now the roles and job descriptions and broadly these demand for skills and core competencies is mapping, where we you know deep dive into the third point. And then obviously your natural disposition would be having this happening, and this is imminent, and the risk of some of the legacy jobs quickly going away, how to plan our careers, how to plan our career moves, where we should focus on in next 3 to 5 years, in very maybe short to medium term, and what would be our strategy. So we would maybe conclude with that to maybe cover the entire thing. So first of all, right, uh, as you may see on this slide, so this is a broader you know contour of what is basically happening in the banking, fund, investment, and financial services industry, right? So as you may see that there are multiple trends which are converging and pointing to the fact that the banks are becoming more fintech firms, by which we mean that most of the decision making at banks, whether it be market investment decisions or credit underwriting decisions, or maybe any other decisions related to maybe policy making or compliance, or maybe fraud detection or anti money laundering compliance. Any key area of the bank is now being driven by intelligent systems, AI systems, and a lot of things have happened contributed to that. Blockchain, which has modernized the ledgers of the bank, right, and allowed them to do the tokenization, right? So the digital tokens is the new currency, right? The tokenized currency is the new currency. So that's has already disrupted with many banks have already been trading in the alternative assets called cryptocurrencies, which is purely blockchain technology based. Cognitive computing, so this cognitive computing is all about intelligent computing, where computer is not purely rule based, but rather more data driven or decisioning based, right? It is smart enough to take decision, right? It is smart enough to take market investment decision, portfolio allocation decision, portfolio optimization decisions, uh, some of the hedging decisions, credit underwriting decisions. uh, uh, so that is called decisioning, intelligent decisioning system, and that has been enabled by a huge wave of AI and ML, right? In memory computing. In memory computing means that we are using the GPU or CPU power of computers to do everything in memory, right? So there's no need for them to, uh, you know, uh, give an output. They will use that particular output within their memory to take a decision. So that is in memory computing. The robotics process automation, which is which has already you have must have heard of, the low hanging fruits of data science, machine learning and AI, that robotics process automation has already optimized and automated many manual laden processes and made them less error prone and less subjective and less vulnerable to any human errors, right? Visualization, uh, visualization is one thing which has now replaced the need for a lot of reports, a lot of management reporting, internal reporting, as well as regulatory reporting. It has moved in a direction where most of the banks and the senior CXOs now have very buffering dashboards which consume real time data from these models or algorithms and tell them what kind of decision they should take at a risk strategy level or business strategy level or compliance strategy level, or maybe a lot of investment strategy level or portfolio strategy level. A lot of variety of uh, strategic decisions are now based on the dashboard, churning out data, real time data, day in day out. Advanced analytics. Now there's one part, and mostly this is from a skill perspective, these things are different, but somewhat confused. There's an overlap. There's one thing called quantitative modeling, which is all about creating those particular predictive forecasting models or those kind of capabilities. Uh, there's another thing called analytics. Analytics means this, that how you are consuming the output of the model, how you are doing slicing and dicing of the output to uh, provide granular level view to your senior management. Like, I want to see the breakdown of my credit risk RWA, risk weighted assets, by geographies, by products, by different customer segments, right? Even to the extent that I want to see top 10 concentrated customers, top 10 single borrowers or single obligors, right? What is their RW, what kind of capital they are consuming. So this whole idea about how you use the model output and how you create those particular filters in some of the intelligent dashboards which allow to do better slice and dice of the data and to look at the problem areas, to look at the opportunities at a very granular level, right, to facilitate that decision making process very specifically to micro markets, to products, to segments, sub segments, to geographies, sub geographies, to business verticals, sub verticals, and all of that. Now, all of this being said, these are the multiple waves which have now converged, and the data requirement of the bank has humongously grown, right? And I'll show you on the next slide that what the data requirement is, right? But that now require making the physical infrastructure, physical way of storing the data, physical way of processing the data, physical way of retrieving the data completely redundant and obsolete. So hence we have a cloud-based infrastructure, a concept called data lakes, right, which is based on some big data platforms like Scala, Hadoop, which create this particular data lake and virtualize your data infrastructure, right? So you need not to have enter at an enterprise level. For a bank, how they're competing with fintech companies is they are also modernizing their data architecture to move from database to data lakes. And this new concept called data lakes is based on some big data technology which can consume big data, which can process big data, which can store big data, which can retrieve big data, right, without any latency, right? Because the data requirement, this is a data age, information age, and the core competency overall of a bank as they're competing with these fintech firms lies in the fact that how agile they are in mining the data, in producing analytics of the data from the data, in you know uh, in doing data driven modeling, in doing data driven decision making, right, in doing data driven analytics, and that analytics which is very real time, right? Not a post facto or a reactive analytics, but rather preemptive or proactive analytics, finding the problem areas ahead of the curve, finding the opportunities ahead of the curve, which micro market, which asset class to invest, which sub asset class to invest, which product is better at producing returns, which segment should we move out of, which new segment, customer segment, which should move new into some of the innovation ideas, how we should customize our product. So from marketing analytics to risk analytics to maybe compliance analytics, the everything is now analytics driven, and this analytics driven specifically with risk management, it has disrupted the analytics wave, which is driving the huge sea changes, has disrupted the risk, how risk management as a function was previously conducted, and how risk decisioning process were previously carried out, right? So there was a survey which was conducted by you know, uh, including maybe some of the stalwarts of the industry from both the AI, machine learning, and data science space, as well as some of the bigger banks and consulting firms. And you know, in that survey, top tier banks were being asked certain questions, and they you know attest certain opinion or certain maybe weightage to all these areas, how much they are investing in new technology, in modernizing their infrastructure, in adopting AI and machine learning for risk analytics and management. So this the below thing, are you aware of, or does your finance team use this? Does your finance team plan to invest in during? So these are the questionnaire which is being asked, and the survey results have been then compiled together and presented on this particular slide. So in crux, this is an area of high performance and high uh, real time analytics uh, mm, uh, driven core competency, and that is once somebody is able to garner that advantage, they are definitely going to have a better advantage in market in terms of the go to market strategy, reaching the customer faster, process, maybe fulfilling maybe the requirement from customer acquisition to customer onboarding to customer uh, risk management to customer maybe business value proposition to customer maybe upsell or cross sell opportunities. Everything maybe is going to be based on data and analytics, right? So that's maybe one. Now just to corroborate that point and tie it back, right, to where we said, okay, data is a tsunami. We are living in a age where data is becoming very commodity, and there's a huge tidal wave or tsunami wave of data, right, which is coming. So you see that maybe data, how data requirements are increasing day by day. And now one small point to make over here, right, that today's data, the modern day data, is not just maybe growing in volume. It is growing in variety as well. So we have audio data, we have social media data, we have geo satellite data, we have imaging data, we have video data, we have like maybe whatever, you know all the analysts and top market analysts and market pundits and asset managers and portfolio managers, whatever opinion they express on the Twitter or X platform, right? We have a way of extracting that data from you know Twitter, their Twitter handles, or maybe on the X platform, and then maybe using that particular opinion to build a sentiment indicator. What is the thriving sentiment in the market under a given market condition, whether it is bullish, bearish, or neutral stance, whether on a particular index or a particular micro market, on a specific stock or on a specific industry sector indices, or maybe anything, economy, anything. What analysts are saying, what is the thriving sentiment in the market. So I'll now link it to the other slide where I'll show you that real time analytics and this data churning algorithms are making it possible to build a behavioral model. So we are moving away from the typical old style risk modeling of scorecard based modeling to this new area which is called behavioral modeling, right? How market is behaving in real time, what kind of price risk different investors are pricing in, how the borrowers default are happening, what is the recovery trends. All of this, you know uh, is basically making it possible to uh, uh, see things in a very surgical way and take decisions faster than others, right? So there are two now. To summarize the first two slides, what I said is that banks are trying to become fintech as fast as they can. They're rebooting their business model, rebooting their business strategy, right? And the kind of funding and they are raising from the market, be it equity, CET1 capital, common equity tier 1 capital, or whatever funding they are raising from the market, that funding, the new capex is all going in AI, ML, data science adoption to modernize their system, to to make invest in big data platforms, cloud computing, in memory, processing, or maybe, and doing replacing those particular old style scorecard model with behavioral modeling as much as possible in the areas, as well as trying to leverage the alternative data set, where like I took an example that if you know the some of the data, like if S&P, Moody, Fitch, or many credit observers or credit risk agencies express their opinion that okay, they are maintaining, they are the rating on a particular company as stable, or they're downgrading or upgrading, what is the guidance, future guidance, is not that a forward looking information? Yes, it is, obviously. If an equity analyst is expressing its opinion in the market on these platforms about the forward looking guidance, revenue guidance, or EBITDA guidance of a particular company, is that not a forward looking information? Yes. The scorecard way of doing modeling was backward looking. Whatever was captured in the financial statement or public available information, right, was captured to do the analytics or predictive analytics. But now it's an age where we are departing from that huge time. We are moving in a direction. The direction of travel going forward is that how to do behavioral modeling, how to do sentiment driven indicators, how to sentiment driven indicators into our models, and how to do real time analytics, right? If an event is happening, if volatility is changing, a geopolitical event is happening, some sentiments are changing, right? Some market behaviors are changing. The market is changing in a dynamic way. So we are departing from static way of doing modeling. Rather, we are moving in a direction where models should also change, because model is nothing but a mimicry of the market, right? When we build a model, whether it's a market risk model or credit risk model, it's a mimicry of what is happening in the market. You are building it using your own portfolio or using your own data sample, but you are basically trying to replicate what is happening in the market, in the what is a broader trend. So uh, so the keywords are dynamic modeling, dynamic risk modeling, right? Behavioral driven risk modeling, sentiment driven risk modeling, data driven analytics, right? Uh, Retiring, or maybe decommissioning those kind of models which were purely theoretical models, purely based on assumption models, moving away from theory and assumption based models to data driven models, like CAPM, capital asset pricing model, or like which is in portfolio risk management, or your even for that matter, any kind of credit risk model which is based on Merton distance to default modeling, right? All of these need to be departed, and we need to do the modeling using AI and ML techniques, which is purely data driven. Now, the data will tell us what is the pattern which should be used for predicting or doing analytics, rather than some theory around ideal condition and some of the assumption that this is how things should happen in the market, right? We are far away from that, right? So that's the thing, right? Now, in the same spirit, now I'm going to cover maybe what is the how this risk management landscape has been changing. So the first point is pretty clear. The follow on from what I already covered, that from static modeling to dynamic simulation approach. So instead of creating a static model with a set of variables to predict your probability of default, loss given default, exposure at default, value at risk, expected shortfall, volatility, anything which is required for risk measurement, right? Portfolio risk, right? Portfolio var, right? uh, we could use maybe a simulation based method, right? We could generate market scenarios. Even if we could use generative AI to generate some synthetic scenario. Synthetic doesn't mean fake. Synthetics doesn't, it's a misnomer that whenever you say synthetic, it means it is perceived as fake, it is perceived as fabricated. No, there are ways to prove that those particular scenarios which, using a gen AI capability, if we are able to generate, those are plausible scenarios. There's some likelihood, there's some possibility of you know those kind of scenarios happening in near future. So you could simulate these scenarios, and under those scenarios you could calculate whatever you want to calculate. You could calculate your exposure, you could calculate your default, you could calculate your recovery, you could calculate maybe your concentrations, you could calculate your provisions, you could calculate any damn thing which you require for your uh, key decision making for running a bank, running a financial institution. So new computation model, which are, let's call those kind of models a scenario aware model or a time series simulator model, are replacing the static PD, LGD, EAD based model. The PD model is for default, LGD model is for recovery, and EAD model is for exposure, right? That's the huge change, and you will see this change panning out, if my hunch goes well, in next 5 years. You know, banks have set themselves some timelines that in next 5 years we are going to radically change the model landscape, the risk model landscape. It is just that it is comforting regulator to accept this new way of doing modeling, right? By proving, by doing more proof of concept, by backing the facts with more data, by showing that the results under this new modeling approach or methodology, which is a scenario aware or simulation driven or time series simulation driven modeling, is more accurate and more precise and more aligned with the dynamic approach than a static approach, right? Which doesn't move a needle even if the market drastically change, as we have seen during multiple crises. The second aspect, which is equally important, is that previously the risk management landscape has been done in a very siloed way, right? You had credit risk, you had market risk, you had counterparty credit risk, you have operation risk, you have liquidity risk, you have funding risk, you sometimes measure collateral risk separately, a lot of. And nowadays a new risk has emerged which is called climate risk, right? Which is called climate risk, and that climate risk is measured, the formal name is environmental, social, and governance for this climate risk, right? Even fraud risk, all of these uh, were managed in a siloed department, siloed functions, siloed systems, siloed databases. And when your CXO, CRO had to take a decision, CRO or CFO or CEO had to take a decision. The decision was how to aggregate across these different tribes of risk to take a decision on a particular counterparty, on a particular asset class, on a particular investment, on a particular market investment, whatever the case may be. Now, that was the fragmented or siloed way of doing risk management or running the risk management as a practice, right? Now, the new norm is, this has already become a norm. One data lake, right? One view of the risk, right? Compiling all different uh, risk tribes or risk perspectives on a particular position, on a particular uh, counterparty, right? What is the uh, credit risk owing to this counterparty? What is the market risk owing to this counterparty? What is the counterparty credit risk owing to this counterparty? How much l- you know funding we have to raise to fund the exposure to this counterparty? Integrating all kind of risk into one uniform holistic measure, right? Which could then drive your capital requirements, RWA based capital requirements, provisioning requirements, IFRS 9 CCL based provisioning requirements, and portfolio management uh, risk appetite decisions on that particular counterparty, whether we should lend to that particular counterparty or not, whether we should increase our limits or not, whether we should extend new facilities or not, whether we should renew the existing facilities or not, all the key credit decisions could could be taken by compiling all the risk. So, and this is one part of fragmentation, how the today business is very much fragmented by risk, right? Different risk teams, different risk systems, different risk data basis, right? The other part of fragmentation is business fragmentation. Oh, I'm part of investment bank, I am dealing with some counterparty. I am part of corporate bank, I am dealing with the same counterparty. I am part of commercial bank, I am dealing with the same counterparty. I am part of merchant bank, I am dealing with the same counterparty. I am part of wealth, I am dealing with the same counterparty. But counterparty is same, right? It's just that different function, different uh, business verticals are giving different kind of products and services to the same counterparty. Now, an integration happening, the data integration is also happening across these business function. That, okay, now aggregate your exposure across the different business verticals, sub verticals, aggregate your risk, right? And tell us give us an integrated view of the counterparty, how much trading limits you have against the counterparty, how much banking book limits you have against the counterparty, how much of maybe uh, climate risk exposure you have against the counterparty. All of that should now converge to one single view on the counterparty. So that's where we call that maybe uh, the data is huge, but now the requirement is more on compiling, integrating, and aggregating the data for meaningful holistic view or holistic risk view or risk assessment or risk evaluation on a on any counterparty which the bank is dealing with, or any position, market position, which the bank has taken in the markets, right? So this is the second tectonic shift which is happening in risk management. So uh, obviously now this clearly indicates, the second one indicates that you would be requiring more data scientists, right? You would be requiring more data scientists because a data scientist is good at statistics to pull together how, you know these different mm, market risks or credit risks or ops risk, which are very different. They are not linearly aggregable, right? How to aggregate them, how to have a joint distribution across different uh, risk uh, factors, credit risk or market risk, how to create a joint distribution, right? Some kind of a statistical understanding or statistician skill is required. A data scientist skill is required to do this particular task, and to do this particular task in the analytics language like Python and Julia, which we will talk about later, right? The third is, I have already covered, but departing or decommissioning, departing away or decommissioning the rule-based models in favor of behavioral sentiment-driven models, right? Using the AI and machine learning. Now, people generally naturally ask that what is so different in AI and ML techniques, which is not there in numerical methods or statistical methods or statistical or numerical techniques, which make this thing possible to build sentiment driven models, to build behavioral driven models, right? To depart from typical rule based models, right? The 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 unique part about AI and machine learning thing, the techniques, is that they do not rely on any theory. They do not rely on any uh, assumptions. That's why sometimes we call them theory free or assumption free models. They simply take the data, whatever the distribution is, whether the prices are log normally distributed or not, right? That depends upon data, right? They would not assume, they would not forcefully transform, the price series into log normal distribution to an extent in some cases where there are certain sorry, there are certain market noise in the data. After removing denoising the data, if more or less the distribution look like log normal, yes, they will do that stuff, but they won't go ahead and drastically change the distribution if it is definitely not log normal. So the data driven way of modeling is whatever data tells you, whatever data insights tell you about the reality of how market is behaving, you should incorporate or you should build that, rather than doing a lot of data manipulation to align it with the broader market understanding how an ideal market should function. In an ideal market is arbitrage free, ideal market is doesn't have any entry exit barrier, doesn't have any transaction costs, blah blah blah. So no, not that kind of thing. So the key point here is that machine learning and AI models are very adept, and they have the prowess to use harness the data, to mine the data, to perform data mining, to create modeling insights. What are the distributions of data, statistical distribution of data, how the data look quantile by quantile or percentile by percentile. So a lot of pre-analytics is also happening before a model is built, so that we have to rely as less as possible on any theory or any assumptions, right? So graph-based hierarchies, graph-based hierarchical models, behavioral models, some of the preemptive alert-based models, right, which are event-driven models, are now embedded in many credit life cycles. So this is an example of how we are departing away from rule-based to behavioral models, right? Uh, the next point is the ask from front office or from business to produce real time analytics, right? So that they could take their portfolio decisions, they could take their allocation decision, portfolio allocation decision, or portfolio rebalancing decisions in real time, right? From reactive risk management to proactive risk management, right? So here maybe a lot of thing computing power, the knowledge of how the computer works to produce real time analytics is handy, right? Should be one of the skill where people should know that gone were the days where CPU were used. Now it's a day of using TPU, tensor processing unit, or the graphic processing unit, because most of the advanced computers are equipped with the graphical user interface or graphical cards, right, where you could do distributed computing, parallel computing to perform a particular task which used to take, days, if not weeks. Now you could do in minutes, or maybe if not ours, right? But how to do this in real time, right? How to generate scenarios in real time, like something happening, us Israel and Iran war, or how it has disrupted the supply chain, what is its knock on impact on the portfolio, uh, the Russia Ukraine conflict, the prolonged Russia Ukraine conflict, what is its knock on impact on maybe portfolio, COVID-19 or any pandemic, what's its knock-on impact on portfolio, right? A lot of these things, a big, huge counterparty defaulting in the market, what's its knock-on impact on the entire systematic risk and our portfolio. So a lot of these particular bespoke scenarios, bespoke analytics produce in real time, right? Both bespoke in nature, very specific to the market, what is happening in the market as on date, currently, and what is panning out, right? As well as doing it in real time is the focus, right? And this will allow us to calibrate our exposures, to calibrate our valuation adjustments, to calibrate our portfolio allocation and decision, right? What to allocate to which counterparty, where to cut the exposure, where to increase the exposure, how to rebalance the portfolio, whether we should uh, move away from certain position, wind down certain position and wind up new positions. Those kind of decisions would be based on, going forward, would be based on purely real time analytics. Risk data integration. So there are certain technical elements to it that maybe many of the multi-source data integration is now performed by some very high highly potent technology, like use of data mesh and semantic layers in the enterprise data architecture. So this is just a technical point to relate to the business point, that maybe from these sources emanating from different risk should be integrated somehow, and data mesh and semantic layers uh, are used. Most of you would remember that BCBS 239 gave principles. The Basel published a paper called BCBS 239. It gave principles, learning from the lessons of the crisis, Lehman crisis, post Lehman era, that the data in the banks was so pathetic and so uh, irreconcilable that you could not even get to the source of the problem. Where was the risk? Whether the risk was at a product level, the risk was at a customer segment level, the counterparty segment level, the risk was related to a particular market or sub-market, the risk was pertaining to a specific geography or sub-geography, the risk was related to maybe some of the desk which were involved, which could mean, by which mean the pricing risk, that some desk priced it wrong, right? Where was the risk, right? When for the quantitative impact study, the Basel pulled all the data across industry, BFSI industry, it could not get to the risk. What was the risk behind those CDOs, credit default obligations, or RMBS, residential mortgage backed securities, which busted, right? So so the data aggregation is a requirement. That's why the multifaceted view on data, right, where the risk data should be aggregated across different risk types, across different risk sources, is indispensable requirements as on today. What we are additionally saying is how tech is enabling this, because when you go to a fintech firm, their business model is every uh, you know thing, maybe some bigger part of, you know a bigger chunk of a bank which is engaged in, you know uh, uh, engaged to do certain processes, procedures, they are trying to replace it with technology. So here I'm telling, data mesh and semantic layers in enterprise wide data architecture allows you to do the multi-source data aggregation. Rapid model development, that is very key, and you must have heard of a word called MLOps, right? Just similar to DevOps, MLOps. So first of all, the rapid uh, model development is that nowadays we need not to just build a model and then forget it for quite few years. We need to keep redeveloping and rebuilding new models, and maybe redeveloping the existing models. How to do that? So for that, most of the banks are moving away from the many fee-based languages, or paid languages, to uh, free source or open source languages like Python or Julia, which has better libraries, more community support, which keep on developing new methods, new techniques, whatever comes to the market. The community, the developer community, Python developer community or Julia developer community is so huge that they keep contributing, they keep building those functions in the Python libraries or modules, right? So however, when it comes to SaaS, right? Every time you have to pay, if you need a customized custom built function, you need to pay the SaaS. So they are moving away from those uh, you know paid languages, and the direction of travel is to leverage the free source or the open source languages, where maybe not only they are evolving faster and with more potent functions and custom built functions, but there's a huge community support as well, right? So that's the first one, how to do rapid model development. Because suppose if I have to do it for a very complex exotic derivative, I have to do a pricing model, right? I have to build some custom built functions, whether in C or C++ or maybe any of the languages, programming languages. But when it comes to Python, right, specifically for AI and ML, right, you have all the different functions, and each year every function has a variant, right? Which addresses a specific product feature or a specific product nuance, right? So how to leverage these particular languages, that's the ask. And that's why maybe from a skill perspective it is very important to be very well versed with these modern day analytics languages, right? And the second part here is that banks have realized that most of their workforce is not trained on coding. So they are building using generative AI a capability where a code could be generated by generative AI, right? You need to just do the prompt engineering. So they are moving away from hardcore coding to a low code, no code kind of a language where even a business user or a risk professional who is a domain expert in risk could code as well, right? So that is also paving the way for rapid model development, right? The third thing is API. Nowadays, API, the data is not like you need to run a batch or you need to run, fire SQLs to get the fetch the data, external data, right? Or from, some data vendor, right? Uh, they based on the subscription, like mostly Morningstar or maybe the big data providers in general, S&P, Moody, Fitch, Morningstar, Bloomberg, right? Thomson Reuters, they have started giving the API key, API, right? Application, programming interface, where you could directly log in into their system, their application, and you could fetch the customized data based on your specific requirements, right? So the most of the so this will cut down the task. Like a model, risk model used to take almost a year few years back, it has now cut down to 3 months. In every 3 months somebody is building some of the model, and the idea is that if this would be further made low code no code with API integrated framework, architectural framework, uh, as well as with some of the skill enhancements or skill training of the staff, right? That some basic Python understanding should, or Julia understanding should be there, right? Then I don't think maybe the modeling would take more than a month or 2 months, right? And everyone can model, anyone can model, and everyone can model. All you need is the right mindset, right, to understand, right, what modeling entails, what kind of statistics, mathematics, or maybe the the principles of modeling are required. What How to build a model, how to think about doing some analytics with data, doing data mining, right? Seeing for some patterns, how to exploit those patterns to build a model, and how to use that particular model, evaluate that model, validate that model, right? Benchmark that model, deploy that model in a cloud infrastructure. All these things require training, right? But once that is done, the new workforce would be uh, would create the idea of that new business model where a bank would transition seamlessly to become a fintech firm, right? Okay, so this is one of the example for you to consume, or maybe if the time will warrant, we will cover at the end of the session how AI and generative AI is used in credit risk management across different stages of credit risk management: pre underwriting, post underwriting, right? So, uh, at what stage, what has now been proposed to be done by using AI or using Gen AI, uh, solutions, right? How we have solutionized and cut down the go to market time, right, from pre underwriting stage to post underwriting stage, right, and performing the risk management in a unified, in a very holistic fashion, right? What all we are doing there. So this is a clear map of front to back use of the footprints of AI and Gen AI in credit risk management. Maybe we will cover and deep dive if the time will allow. But moving on to moot points, before moving on here, one thing which I wanted to showcase you as part of the changing landscape, right, that when it comes to risk management and risk quantitative risk modeling and analytics, right, how things have changed, right, and where we are at this stage. So we were, when the vaguely the word called model or the word called modeling came into picture, we started with a stage which was called descriptive analytics, where the idea of a model, what a model was supposed to do, it used to consume data, right, and summarize what data is showing, right, what historical data, based on historical data, it used to summarize what has happened, right, which was in that era made sense, but where the markets were stable, right, and uh, we were not hit by crisis every then and now, right, for decades the market was stable, right, and descriptive analytics made sense because it, yeah, essentially philosophically what it used to say, whatever has happened in the history will repeat itself in the future, right. The market might be perturbed or small, be hit by a small time mm, very short lived crisis, but it will go back to its historical state, right? Hence historical analysis was done using these models, right? Then came in the era of diagnostic analytics, which was pinpointed whatever happened, why it happened. Diagnose, identify the cause, look behind the those particular things which have happened. It's good enough to tell us what has happened, right, in the market, like saying cross defaults, domino effect, right? That a big counterparty like Lehman defaulting, a big broker dealer or investment bank like Lehman defaulting, led to a lot of other broker dealers which were dealing with Lehman also defaulting, right? It means that ideally, if somebody would have known, then they would have created a joint probability distribution of Lehman and its counterparties, dependent counterparties. I'm just taking an example. So telling, okay, this has happened, cross default has happened, right, uh, is not enough, right? Why it has happened, right? And diagnostic analytics, so it was moving, we just were moving towards maybe inching towards somewhat a behavioral finance topic, a behavioral analytics topic, where from typical scorecard models we were just started looking at, under the diagnostic we started looking at, right, why it has happened, right? Predictive analytics. So this was whole backward looking. Still, we were relying on historical data. Then come came the age in late in early 2000s of predictive analytics, where we started not only using historical data, but we started using some other, future scenarios like Monte Carlo simulation or scenarios to do prediction, right? Historical data plus some future scenarios, to do the prediction, right? So that was predictive analytics. Not only what happened, why it happened, what could possibly happen in the foreseeable future. That was the idea of predictive analytics. Now, this cut this down. From here on is the AI and ML led disruption, which has further created, you know, maybe made us achieve, you know, pivot towards a new landscape, and that new landscape is prescriptive analytics and adaptive and autonomous analytics. Now, what prescriptive analytics means? That, okay, you have explained what has happened, why it has happened, and what could possibly happen in the foreseeable future over short term or medium term or long term. Build an intelligence into your models, right, to tell us what kind of decision we should take if a particular crisis were to happen. If a crisis is predicted in the near term or mid term or long term, what we should do, how we should recalibrate our risk strategy or business strategy, how we should rebalance our portfolio, how we should cut our risk appetite, how we should, you know bring back our concentration levels on certain product segments, counterparties back to, under the risk appetite, right? How we should change our pricing, how should change our capital requirement, what kind of capital buffers or stress capital we should keep as a loss absorbency capital to absorb any kind of losses which could uh, you know which could maybe manifest under those particular scenarios if they were to happen, right? All those kind of questions, right, answers are recommendation kind of thing, where the AI algorithm is used. It is not only predicting output but also recommending you, prescribing you that, you know if this were to happen in the foreseeable future, this kind of decision I would recommend you to take, right? So decision making engine. So far it was not decision making. It was uh, you know something models produce. We done some analytics, presented it to our exco, they took the decision. Now the era is that how to make this particular models as intelligent decision making machines, right? Once we realize that, and a bit of uh, another topic like quantum computing, the processing power, we need to, achieve higher processing power to be able to do what the promise which is given by adaptive and autonomous analytics. What is adaptive and autonomous analytics? When you make a system so intelligent that you can fully or maybe partially trust the system to take decision without any human intervention, right, is the idea of full AI, full fledged AI, or adaptive autonomous AI, where the that particular robo advisor or wealth advisor, like many of the wealth management professional or portfolio management professional, they are getting replaced by wealth advisors and robo advisors or portfolio robo advisors or wealth portfolio robo advisors or private robo advisors in serving the clients. But still, human is in the loop, or human is there for oversight. One day these system will become so intelligent, so intelligent that there's least human intervention required. There's just an oversight, light oversight or governance required as to ratify that particular decision which is taken by the robot or that AI intelligent system, AI enabled system. But that's all, right? That's all, right? uh, right, you could ratify, you could override, you could adjust that particular decision, you could calibrate that particular decision based on your subjective understanding of your shareholder expectation or investor expectation or market expectation or market outlook. That's it. The rest major part of that particular decision is uh, correct as taken by the AI driven platform or AI driven uh, system, right? So that is where it is now. All of this, if you summate that, now it creates both a hypertension and a hyper excitement as well, and a feeling of acceleration. Oh, so much is happening, and this is an exciting world. And more than that, a hyper anxiety that if this were to happen where we lie, are we going to be replaced, or is whether we have a career, right? I would say the same happened during the computerization age, where people were very, seeing it very from their perspective in a very, how to say, uh, mm, uh, short-sighted way, right? This for next 20 25 years, right? And mind my words, it's not my words. I have read into Gartner studies and various studies, well published studies from Harvard, Cambridge, Gartner's, and Oxford's, and all of Wharton and all of that, right? That in next 2 decades, the net impact of AI and generative AI, right, is creating jobs, because there's so much for these legacy banks to do, right? So much transformation to do that they cannot afford to be behind the curve. When they're competing, they're not competing amongst themselves now, they're competing with their peers, and that peer is fintech now. So the fintech firms will keep them on their toes. Nutshell, a lot of jobs are going to get created, right? And those jobs are not going to have a knock on impact on existing jobs, slightly, to the extent if somebody is just doing very operational job or very maybe uh, sort of a document trail job, right? That kind of low hanging job might go away, and definitely will go away. But other than that, most of the value added jobs in risk management and risk uh, space, risk modeling space, will remain. The only thing is the knock on impact would be starting to feel after maybe 5 years or 7 years from now, when many of these particular, most of you and most of us as well, would be expected to build up their skills and core competencies. And if we are missing the bus, and if we have, still contemplating whether we should get on to learn data science, AI, machine learning in the context of risk management and modeling, if we miss that particular bus, and if we are not onboarded and that particular bus on psychologically, on mental level, then definitely, right, we are uh, digging our own grave, whosoever is, right? If right, so the idea here is that to increase your awareness level, right, and to get onto something where you should be technically trained, right, for the requirements of or demands which are in demand skills and core competencies desired by the industry. For next 2 to 3 years, you give yourself with conviction that time, and then the strategy is that give yourself time, maybe 2 to 3 years span, build these core competencies, and the idea there is then start moving into a role which is not just pure risk management role, but a amalgamation of risk management, risk analytics, or risk modeling role, right? Which, let's call it hyphenated roles, which are very much nowadays coming up. So the idea here is to map the core competencies or skills required on one side in demand from industry, and the kind of roles which are coming up. You must be coming across multiple JDs, job descriptions. At IIQF, we have a panel of faculty or some of the eminent professionals, academic as well as from industry, we do this as a quarterly review exercise. What we simply do is we take out the job descriptions which are uh, compensation wise good and which are have high growth opportunities, high career growth path tracks, and we pick up the key skills uh, demanded on there, and then we this is a outcome of, broadly you could say this is an outcome of that only, right? That nowadays, right, uh, the advanced programming has become a skill. Do the uh, uh, you also at an enterprise level, I told you that many of the firms have started working on low code no code platforms, but definitely for somebody to hire in a cream position, they need advanced programming skills and proficiency in analytics languages like Python or Julia, right? Data science skills. Now, uh, whenever I am saying that, okay, we need to produce one holistic view of risk, we need to integrate, or this was not simply data integration. This was a, uh m- quantitative integration of multiple resources, multiple risk types, multiple risk tribes into one aggregated risk measure, which require a data scientist skill, which require somebody to know statistics well, to manipulate the data, to transform the data, and to visualize the data through various plots, charts, graphs, distribution plots, quantile by quantile plots, a lot of analytics plots, not just simply dashboarding, right? Analytics plots are different. They, are, they produce statistical insights, like is there an arbitrage opportunity, is there statistical arbitrage. Looking at the trading data, you could then advise that we should build a statistical arbitrage strategy. Sitting at a hedge fund, that is very key for a data scientist to do, right? Building models, quantitative models, which could do the those particular maybe either trading or lending or maybe book running or M&A advising or maybe treasury support or liquidity management services, cash management services. All those businesses, right, are thriving to build models who could do those particular tasks of doing predictive and prescriptive analytics. And those, as I told you, would be require you to understand the AIML techniques at its deep depth, mathematically, methodologically, application wise, right? Understanding it. Not necessarily you might be become a model developer, but even as a risk professional, when you would be using the output of those particular model, regulator might ask you, auditor might ask you, model validator might ask you, even your exco might ask you, what does this mean, right? What does this output mean? How to attribute to risk that particular risk to different risk factors or risk drivers. So that any which way you are doing today, right? You do P&L attribution. When it comes to default, you do attribution to various leverage ratio, liquidity ratio, turnover ratio, profitability ratio. You do attribution in some sense. Okay, the rating is this because the leverage is bad, right? Okay, right. P&L attribution you do to different maybe risk curvature or this, you break it down, right? But using an AI and ML model, unless you understand how an AI and ML model functions, what are the mechanics, what is happening under the hood, how you would be able to even keep doing that, right? Suppose if everything on the modeling side would move away from traditional numerical or statistical models to AI and ML models, right? So you need to understand these models well. The third, so that is also the requirement. Most of the JDs also feature that uh, whether you know neural networks, whether you know generative AI, whether you know LLM models, whether you know supervised learning, unsupervised learning, semi-supervised learning, all of that, right? Based on the requirement of that particular specific subdomain, right? Uh, then maybe the financial risk applications. So not only these techniques, right? What we generally do in our courses is we first of all elicit interest by giving a case study or telling, okay, this is the use case, and do a reverse engineering, right? Having this problem statement or use case or this kind of data, right? What could possibly be done? What are the challenges in the data? Right? Whether the data has noise, how to denoise that particular data. Whether the data has outliers, how to remove outliers or extreme values from the data. Whether the data requires some transformation, how to do that particular transfer. So the starting point would always be a problem statement which would marry tie it up these particular techniques with the specific application area, so that you need not to wait at the last juncture to understand, oh, this is the application. The application is elicited right at the upfront, so the application is very much in focus. That would sometimes make you unique out of your many other the competition. You could because when you know the application, right, many of these banks are looking at talent who could guide them in adopting AI and ML for the right use cases or applications, right? So that's also one of the requirement, which we call AI and ML researcher, right? Who research new areas or new use cases or new applications of different AI and ML techniques, in specific domain like fraud analytics, or maybe AML compliance, anti-money laundering compliance, or maybe credit risk analytics, or market risk analytics, or operational risk analytics, or enterprise-wide stress testing analytics, or portfolio risk analytics in specific domain subdomain, right? They require people to who know, who could put their mind and wear that particular hat to come up with the application areas of using leveraging gen AI, or leveraging the machine learning techniques, or leveraging other forms of AI in their area to increase the footprint, right? Last but not the least is uh, the some architectural understanding, which is the technical bit, which I suppose maybe in this slide when I was saying rich data integration required data mesh and semantic layers, blah blah blah, and rapid model development needs API integration, and there's so some architectural level thing, how to do parallel computing, distributed computing, right? Uh, how to use APIs, right? How to use write a modular code, right? Those kind of architectural details, front to back architecture or tech stack required. What are those big data platforms or big data technologies, big data infrastructure, maybe, right? So cloud computing, all of this design and architecture, some kind of understanding. Though we are not IT, but we would be heavily dealing with IT, right? Once we start, using these capabilities at an enterprise level. So the kind of roles which are coming up, I have just for a simple view capture this by skimming through multiple JDs, but the kind of role you would be now seeing in next 3 years, you would see that a lot of roles have already started coming, and this would you know maybe to my understanding multifold growth will happen, or maybe multifold requirements will come up quarter on quarter, year on year, right? Data scientists, somebody who understand statistics well, and who know how to play around with data, do data manipulation, do data exploration, data manipulation, data transformation, data processing, data uh, aggregation, right? Data visualization, data storytelling, right? Data scientist, right? Data engineer, one who know the This is a more techie role, and those who of you who are in IT and employed by different banks, uh, big data platforms, Hadoop, Scala, Spark, or maybe Hive, or these kind of how to do uh, 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 use big data platforms, how to implement data lake, and how to deploy you know your data on a cloud-based infrastructure, right? AI and ML developer, right? This is again a very techie role. They might not require any understanding of the domain. They might not have any domain specialization. They might also not have very methodological understanding of AI and ML techniques, but they are developers. They are good at Python and they're good at Julia or those developers. AI and ML algo designer. This is an architecture, right? So there's a developer, there's an architecture. So the IT architect or system architect is algo designer, right? Product owner, which is a uh, cross in in the agile world or agile methodology. We have this product owner role, which is a combination of domain specialization. Yeah, you are an expert in credit risk, market risk, counterparty credit risk, ops risk, enterprise risk, blah blah blah, right? As well as a bit of IT side of things as well, right? How the IT world work, what technology stack, tech stack they use, their lingo, their language, their parlance. You act as a bridge between the risk function and the IT development, right? uh, AIML researcher. From now on, AIML researcher is one who is an expert in AIML methodologies. Somebody who will tell, okay, which kind of neural network should be applied for solving this high dimensional problem of pricing an exotic derivative, right? Now, it- because that person has done a specialization in deep learning, or it they have used almost maybe at a level of depth, they have covered most of the neural network which are used to solve multiple high dimensional problems across finance and risk, right? So it's somebody who knows domain well, domain expertise like a FRM or a risk specialization, as well as who understand the data the sorry the machine learning and AI methods used in a particular risk domain or subdomain, like maybe what is used for PD LGD, like random forest, or some of the supervised learning technique like ADA boost or XGBoost are now a lot of those are used for PD LGD modeling. So if I know that what is random forest or the methodology of random forest or XG extreme gradient boosting machine or some of the those particular things, and I know credit risk as well, I could be a AI and ML researcher, right? Computational quant researcher is the one. People develop models, but then there's someone who use the who is given a task of using the computing power well. Many of these models are very uh, they are how to say, they require a lot of processing power, right? Computational power. Now, how to use GPU or TPU maybe tensors or graphical user, how to use graphical processing units or TPUs, right? To do parallel computing or distributed computing, how to bring down the runtime of a model, right? To produce real time analytics, that is computational quant researcher job. Quantum computing. So, as this is a futuristic role, you would not see it now, but as the quantum computing are uh, getting qubits, or quantum computing are getting evolved, right? High performance computing is coming into play, right? And that will create another set of roles who know how these quantum computers work and how to harness and leverage their capability for doing complex solving complex problems like exotic derivative pricing, or even some of the portfolio allocations in real time, right? And then obviously project manager and program manager, more so some of these roles like product owner, project manager, program manager are more required because now the more the tech or IT content of the job role, there would always be somebody required to bridge between business and risk on one side and IT on another side. So that's why maybe I think that more such projects would be commissioned, more would be requirement of somebody who could manage such projects, who could talk on both the sides and see right how to manage the entire book of work. So that's project manager and program manager. So that's just a mapping. On here I have just given a flavor of some of these uh, uh, mm, rules into very short description of uh, under a lab environment and factory environment. By lab environment we mean that in theory, right, when somebody is being trained, right, in factory environment when they perform the role, right. So how different roles, right, you know, what is the basic requirement of a role, what is the requirement of product owner, what is the expectation from data scientist, data engineer, right, those kind of all kind, broadly speaking, right. So some of these things could be, and there are other slides as well which are for your consumption, right. Whenever we were talking about a lot of these analytics, right, right, some of the facts which have been taken out, uh, trends, right, industry trends, that the worldwide data is hitting maybe 170, as has already hit 175 zettabytes, right. Uh, and we would expect more data to come because there are many IoT devices, right? So the more the data, the more the huge the data tsunami, the more the pressure on these firms to do data mining and to take database decisions, right? So broadly, you could read through some of these, right, which are uh, broadly the fintech driven revolution or some of the trends which are disrupting the financial markets, right? So that's maybe all for now, and maybe there are further few slides for you to maybe just grapple with, maybe uh, and maybe that's it. I suppose maybe more time should be allocated, sometime reasonable time should be given for Q&A as well, right? So I'll just maybe uh, lend back that time to Q&A. Nitish, over to you. Hello, Nitish, am I audible? Hello.
Yeah, hi. Sorry, Sanjay, I was in mute. I didn't realize.
Okay, yeah.
Yeah. Thanks so much for the wonderful session. So, I mean, everybody, I understand you have been very patient. It was a wonderful session. So, you have been all listening to the session very patiently, and we have actually overstood the time a little bit. But nonetheless, I mean, please feel free to ask whatever questions or queries you have regarding whatever Sanjay has discussed. We are looking forward to the Q&A. And before that, like let me mention few things in the while we give a little bit breather to Sanjay for 2 minutes. I'll not take much of your time. And in the meantime, please let the questions. Excuse me. So yeah, please feel free to type in your questions. Right. Okay. So while you are typing your questions, maybe we'll utilize this time to do a quick review of what we do at IIQF. I mean, most of you already know about us, but maybe like again, a very quickly I'll mention. So first thing is, I mean, well, not go too deep into this. Just like a basic few things I would like to mention, right? And I mean, the crux of today's discussion, I mean, was that see machine learning, data science, AI. these are actually becoming what we call omni present skill sets, right? Essentially, anybody work, trying to work in any industry, forget about quant or risk or maybe like again algo trading and all of that. Any industry you plan to make your career, or you're already working and you want to continue in quant, ML is becoming integral part of most industries actually, right? And particularly since today's topic is about understanding about risk management and applications of machine learning and risk management and all that, right? So the other aspect is that risk management, of course, has special emphasis on ML, as Sanjay is, so wonderfully explained to us, right? So that is there now. Like again, so basically, like the people who would be successful in their career, what I personally believe is like people who would maybe like again would be people who would be there actually, like again, who would understand both sides, right? In any industry you want to work in, it should be both the domain as well as like the field of AI in general, machine learning, data science, all put together, right? So at IIQF, what we do is, we are a body with specialized, and we are the pioneers in education in the quantitative finance and financial engineering in India, as many of you may already know. So we have been uh, doing preparing candidates to work in the quant industry for more than 16, 17 years now, right? And we do have various courses which makes people ready to work in different aspects of the quant industry. And now, of course, since machine learning, data science has become very important, right? So essentially, we now have additionally courses on specifically teaching machine learning, data science in context of finance as well. And again, we regularly interact with the industry, and we ourselves work like very heavily into the industry, and we keep ourselves abreast, and all new developments always are put up into the course, so that you are anybody doing the course is always ready to work in the jobs, right? So I mean, those who have an interest in building this kind of career, or where you're already working and you want to go deeper, we have various courses to support your career journey, right? Whether you want to go deep into the field of financial engineering, where you want to go deep into the quant areas, then actually you have this course of certificate program in financial engineering, which is very heavy into mathematics and mathematical modeling, ideal for people who come from mathematics or engineering background, or science with mathematics background, trying to go deep into the quant industry. And of course, this course also has like certain aspects of machine learning covered in this course also, right? And these are this is like an 8 months course, and all the courses that I'm discussing, these are all weekend live interactive lecture based courses, so you can do this along with your jobs, or along with your, if you're doing a degree, you can do along with your degree as well, right? So in the same lines, we have another course called quantitative finance and risk management, very important course for today's audience, because again, if you're interested in going deep into the risk management industry, so this is your course to look at, right? A 7 months weekend course teaching deeply all aspects of quantitative modeling for derivative valuation, pricing, and risk management. A course in the same domain, finance, like financial engineering, but taught in a relatively less math-heavy way and more focused on the risk management side. So this is something which, if people even from finance or economics or those kind of background, also if you have an interest in working in quants, you can do this course and make your career in the quant industry. Now trading, if somebody is interested in that field, right? So trading also now involves, or maybe like again, it's a lot of it is done through automated algo based systems, right? So, and in fact, most of the institutional trades nowadays are done through automated algo systems. And even for retail, it's like a savings figure, and that's like a 2 year back figure I'm quoting, right? Where like 58% of the people, even retail traders were trading through algos. Of course, the figure will be much higher now. So the crux of the matter is, if anybody is interested in trading, then learning about algorithmic trading definitely should be at the top of your priority, because all traders at some point of time ideally should learn how to build algo trading systems. And this is like a course which exactly teaches that. I mean, how to build algo trading systems using different kinds of strategies, technical analysis, price action, to machine learning, to quant model-based strategies, and all of that. So it's a very comprehensive course teaching you all aspects on how to build algo trading systems. And yes, I mean, the last part of the, not last but not the least, actually, I mean, as I was saying that now since machine learning, data science, and AI has become a very, very important part of every industry, and including our industry of quant and trading and risk management as well. And risk management part, we have, I mean, we understood, I mean, in more detail in today's session. So to anybody having an interest specifically to work in the machine learning or AI driven or data science driven roles in finance. So we have very comprehensive courses preparing you for that. There's a course called AI for Finance, which I mean, it's a 10 months, very comprehensive course teaching you all aspects of data science, machine learning, and their applications in finance. I mean, if somebody does not want to do the entire 10-month course, it's like a course which is very modular as well. If somebody wants to do the first 3 months of that program, they can learn the data science part specifically in the first 3 months, data science in context of finance. If they want to only do the machine learning or learn other machine learning areas in finance, they can do the second part of the course, which is called machine learning in finance. And I mean, then it would be a 4 months program for them. And if somebody already have a good background in data science, machine learning, they can directly go into our applied ML courses in different areas of finance. So there are modules related to generative AI for finance, AI for trading, AI for risk management, and AI for derivative valuations. These modules are about 3 months duration, and this actually teaches you how to to understand the applications of machine learning in different areas of finance. So basis your background, basis your requirement, you can actually look to do these courses if you want to understand the applications of AI in different areas of finance, right? So and of course, as I mentioned, if you want to directly do this applied AI courses, then you need to have a prior background in data science, machine learning. If you don't do it, if you don't have it, then actually you can do the entire AI for finance course. And in the final part of the course, you can choose any of this applied modules as your specialization area in the AI for finance course, right? Very quickly, okay, this is something you can go to our website and check. There are many students who have shared their thoughts. You can check. This will give an idea how professionals and students have used our courses to make entry into the quant industry. I mean, in various roles and various at different stages of their career, irrespective whether you are a student or whether you are already working. If you have an intent to go into deep quant and ML or risk management based profiles, you can definitely look at these courses to help you with that. Right. Okay. Very quickly again, so it's our courses, of course, again, we being the oldest quant body in India, the industry connect is pretty strong. And we definitely leverage that to help our students in connecting with the right jobs if you successfully complete any of our courses. And in fact, your journey with us in terms of the job side of things starts as soon as you connect with us, even if you start doing our course. I mean, because before doing our course, you definitely would have a career counseling with us where you can discuss your current scenario, your current, where I mean, your overall profile, and then our experts can suggest you, I mean, what would be the right path for you, right? I mean, if you want to make a career in this part, I mean, what kind of courses you should be doing at, what kind of skill sets you should be acquiring, and what kind of roles you should be targeting. And then, of course, once you are part of the course, then every faculty is an industry leader. So you learn from all industry leaders working in international banks and I mean trading desks, consulting firms, particularly in quant, risk, ML, trading, and all these areas. So essentially, you not only learn from them, but again, if you're stuck in anything, you can seek their help in mentorship as well, right? And as I mean, there's a dedicated placement support team who actually works with you in the entire process, resume building, interview preparation, customizing and profiling your LinkedIn for this kind of jobs, and then sending your resume, getting interview calls. So they help you in the entire process, right? So yes, I mean, target companies we all know. I mean, it can be hedge funds like Renaissance Technologies, DSO, Citadel, commercial banks like JP Morgan, Citibank, Nomura, all investment banks like Goldman Sachs, Morgan Stanley, Deutsche Bank, AMCs, mutual funds, PMS, pension fund, sovereign wealth fund, insurance companies, fintech companies like Visa, Mastercard, Ant Group, Stripe, etc., different financial software and product companies, Numerics, Murex, FatSet, Bloomberg, etc., stock exchanges like NYSE, NSC, consulting firms like EY, Deloitte, PwC, all central banks, regulators, US Fed, ECB, RBI, even World Bank, IT companies like Accenture, Cognizant, TCS. The entire era, this arena, is open to you, right? These are all companies which recruits very heavily from people having the skill sets that we teach, and we do have a support system to help you connect with this kind of companies. There are different kinds of roles. I'm not going deep into that. Yeah, this is again a very small list of organization. Being like one of the oldest quant body, we have practically worked with the entire quant industry, be it the international banks or consulting firms, trading desks, or IT companies. But this is again just a small list for your understanding. And as a part of our endeavor, we have been, of course, working with a lot of educational institutions as well to promote this field of the quant field among students as well. These are again a very small list of some of the institutes we have worked with: IIT Madras, Roorkee, IIT Bombay, IIM Mumbai, BITS Pilani, to name a few, and there are many, many more, right? So anybody having any questions, queries, or any guidance that you need, anything that you want to discuss regarding the courses also, these are like the contact coordinates. You can call us on this number, you can email us on this number. All right. Okay. So maybe let's get back to the session, and maybe like again, let me just collect the questions. And yes, Sanjay, so I'll be
Yeah, sure, sure. I'm there.
yeah, so I'll be collating the questions, and maybe you can answer them, right? Okay, the first question is from Richa, and she says, how risk and quant profile demand currently in market, and what skills should we focus majorly to get into these roles?
So risk modeling and quantitative risk modeling, which embed the elements of building mathematical quantitative models for risk management, right?
Right,
Be it your be it sometimes your pricing model, sometimes your portfolio risk management model, sometimes your credit risk management or counterparty credit risk management or market risk management models or enterprise risk management models or operational risk management model or liquidity and funding risk management models, right? They have very heavy requirements, but broader the role sets or the role requirements could vary from model developer, model validator, model governance, right? Uh, the model auditor. So depending upon, like Nitish was saying, that you could be with a big four consulting firms doing model audit for various banks, right? You could be a model validation part of the model validation team, either with consulting firms who do independent validation of banks models who are hired to do so, as well as within banks as well. There's an independent model validation function, model validator. So the model get developed by developer, the model get validated by an independent team, the model get audited by a different team, the model get governed through the entire life cycle by somebody who is just like a project or program manager who look at different phases of the model life cycle and uh, try to see whether we have adequately documented, meet the regulatory guidance or regulatory compliance checklists, right? We have followed the process which is set out in the bank to develop a model. At every point we are doing policy compliance or to some model policies, model risk policies. So a lot of different variety of gamut of roles are available for somebody who within the risk management space is looking at quantitative risk modeling. Yeah. and
absolutely.
and some of the core skill set would not be different, like statistics, mathematics. Like in interviews you would be grilled on that. The sophistication and the intricacy or the Proficiency level would vary whether you are model developer or model validator or model auditor or model governance, right? But maybe generally understanding of what these models are, right? And how these are built, how these are used, right? What are the assumptions? What is the framework of these models, right? Uh, and how to maybe optimize these models, and in the current era where we are living in, how to build alternative challenger models. I'm reserving the word challenger models based on AI and ML, right? Which could challenge our existing models, which are purely statistical and numerical method based, right? So, an AI and ML expert could find a quick entry into this particular area because even as much as it is a learning curve for somebody who hasn't been into the quant space, it is also a learning curve for a seasoned quants as well to learn AI and ML techniques. This is something new to them as well, right? So they are not very different from many of non-quants, right? So somebody who could quickly, turn around the skill, it into a skill or core competency, could easily disrupt and enter into the quant domain by honing the AI and ML researcher or expert skill. Yeah.
Yeah, absolutely. I mean, that was a very detailed answer, and in fact, I hope that answers your question. Uh, okay, the next question is a little similar, but no, it's not similar actually. I mean, though it's like career related only. So it's like a question from Durgesh, and he is a second year BTech computer science student. So he says that he is more interested in quant trading and in forex for 1 year, but explored quant 3 months back. And I wanted to know how deep is should acha. I mean, how deep one should go. I think in AI, ML, and finance in order to get good understanding. All right. Can you answer that question?
Yeah. The more, Durgesh, a simple barometer of that is the more intricate or complicated the domain is, right? The more proficiency you have to build, right? If you're working in a trading or algorithmic trading or high frequency trading environment, right? You have to be very thorough with building models because their models doesn't stay where they are. They are literally what I covered, like very uh, dynamic models. They keep changing with slight change in strategy. If somebody is playing out a volatility based strategy, and uh, tomorrow maybe it would they feel that the pair trading is more lucrative, right? So they have to all of a sudden start building a model for pair trading, for correlation based trading in between two stocks or between two indices, between two asset classes, between two markets. But whatever the case may be, you got my point that, right, that uh, you need to be very thorough, and specifically not only thorough with techniques, right, which are used AML techniques, but also with the domain, how to tie it back to the application use cases. Because from a requirement perspective, a front office trader or a desk trader would only tell you that I want to play out this particular strategy, and you tell me what data is required, and how you embed that particular strategy using one of the potent technique which could really help me to play out or execute this strategy at fast, right, at fast speed, right.
Yeah, absolutely. And I hope that answers your question, Durgesh. But just to add or maybe simplify it, I mean, from a very practical point of view, I mean, see, trading is like a field in whatever tools you want to use, right? Whether you are using machine learning models, whether you are using, I mean, any finance tools like technical analysis or maybe price action or whatever you want to use, right? I mean, you have to understand that in a very deep level. Money making is never easy, right? I mean, if you are a trader and you are using anything, whether it is machine learning, whether you use general finance, general understanding of derivatives, so you have to be thorough. You have to have a very deep understanding of whatever you want to use in your trading, right? So, I mean, whether if you want to use ML, so you have to deeply understand the ML models that you want to use. If I mean, of course, the finance part, there is no compromise on that. You have to understand the relevant finance areas, be it the markets, be it the derivative instruments, be it the other tools like technical analysis or anything. So whatever you want to use in your trading, it can be even fundamental analysis, economics, or whatever you want to use, you have to have a solid understanding about that, and then only you can actually put it to your into your trading to effectively develop good trading strategies, right? So trading is definitely hard work. A lot of people only see the glamour side of it, but if you ask any trader, they are lifelong learners. I mean, they are learning everything. I mean, every day they are learning something new, right? So yeah, I mean, trading is high paying, very glamorous, but it requires a lot of effort also behind the job, right? So that's a little different kind of summary I just wanted to give since you are very young. So a lot of people just see the glamour side of trading, but it's hard work, and again, it requires a lot of knowledge. There is no end to end, and there is end to it actually. More you learn, the better it is, right? So that's how it is. I like to add on to that, right? Okay. The next question is from Rishikesh, and he says that I am passionate about technology and finance, but I have only little interest in mathematics. Is there any role in the quant field that involves comparatively less math? Oh, very interesting question, Sanjay. Please
Yeah, yeah.
answer.
Yes, yes. So Rishikesh, to your point, so that's why I explicitly, while covering some of the roles, explicitly called out that these are purely IT and tech roles, right? Obviously, some part of maths would always be desired, because if you want, if like uh, in terms of overlapping, if you want to become an expert in some area, you have to sometimes become a jack of multiple trades. That's the market reality. But purely from an IT tech side, I don't think you would be requiring as much mathematics as is required from somebody who is on quant side, right? So for example, the data engineer role require you to be very well versed and deep into the data platforms, right? And big data platforms, and the data visualization, the dashboarding and all, how to build dashboards and all, right? The ML engineer job will require you to how to deploy already developed models in a cloud based infrastructure, right? The architect role would require you to be an architect, how to do front to back architecture or design architecture using some of the design strategy of the bank, how to integrate across various systems, how to build pipeline. And then maybe somebody who is into maybe what to say, automation, could be an expert in ML ops, right? Because ML ops is a new area which is akin to DevOps, how to automate the steps of deployment and the steps of testing while building a machine learning or AI models, right? So all these roles are 90% or 90 to 95% pure tech driven roles.
Yeah, absolutely. Absolutely. So, just to quickly add to what Sanjay said, I mean, he has already explained it well. But the thing is, see, I mean, if you are trying to work in like roles which are an amalgamation of technology and finance, so-called fintech roles, right? Of course, um, I mean, there are a lot of roles, as Sanjay mentioned, where actually maths is not significant, right? It's like I mean, a lot of roles are tech, ML based, and all of that. So you definitely can work. I mean, with very less mathematics or maybe minimal mathematics. But again, what I'll request you to understand is that actually it's always good to know, because you are talking about field which uses a lot of mathematical statistical models, and not necessarily always mathematical. I mean, it can be very heavy statistical models also. So maybe if you want to go deeper into the roles and again maybe rise, I mean, getting comfortable with some amount of maths is good for you, right? I mean, though it may not be necessary, but it can be good for you. That is what I would like to add. And again, the application of maths depends on role to role. Again, as Sanjay mentioned, it's not equal for every role. There are a lot of roles where tech is more predominant. There are a lot of roles where finance is more predominant. There are a lot of roles where maybe like again the domain of risk for these are more predominant. But I mean, so since all of them are underlying, again, you use good amount of statistics and some amount of maths. So if you get comfortable with that, that will help you in like your further rise. But you can stick to non-mathematical roles if you're not comfortable. Just the summary from my side.
And just to add to that, Nitish, if you may allow,
Yes, please, please.
so uh, the other aspect is that we don't teach maths the way you are used to, which
Absolutely.
in the first place, like not like you pointing you, but in the first place made you lose interest in maths, right? We teach maths in applied maths way, how it's been taught in best of the best quant institutions, right? So first you will be starting with a problem, and then you, in order to solve that problem, we will tell you that this entire system can be expressed as a system of linear equations and how to solve that particular linear equation, right? So uh, maths need to be taught in a reverse engineered way, right? We long back realized that, and that's one of our USP. And the other part is for those who have, from their maybe secondary education, have maybe casually, maybe taken interest in maths. We don't leave that stone maybe unturned. We start at a very primer basic level to very elementary level, for even for your coding jobs. Nowadays what we call that, many of these high level languages do vectorized calculation. So whenever we even talk about, some of the computational science aspects, we try to explain the maths behind that, okay, these are happening in vectors and matrices, right? That's why the speed is getting achieved. You know the Python and the Julia, the library and modules are written in vectorized form. All the operation happen in vectorized form. So that will build some curiosity and interest. So contextually, I don't think that you would be as disinterested, right? Learning maths, it's the way how it's been taught.
Yeah, yeah, absolutely agree. I mean, just to give you a very simple example, Rishikesh, I mean, our financial engineering course is the course where we go the deepest in terms of the mathematical theory. And in fact, in the first one or two lectures, a lot of people get a little afraid as well. I mean, I'll put it very honestly, right? And that's like again, why are you we going so theoretical in maths and all that, right? But then like again when they learn the entire module, they see that this is so applied, they start really appreciating, and then the same person actually come back a lot of times. Actually this has happened, they come back after 5 6 sessions and then say, sir, the understanding is so good that I can now study any research paper, and again I am not even from a very heavy mathematical background. So yeah, I mean, just like as Sanjay mentioned, I mean, don't be too much afraid of maths, because this is like a field which is like applied maths. Nobody is asking you to solve mathematical equations. Nobody is telling you like this is like an algebraic equation. You give an exam by solving that. So it's more applied, and a lot of it is. I mean, these are all taught by professionals like Sanjay who have been using this mathematical model. So it is taught in a way which is like where you will find it useful as is used in the industry. So you would find it interesting as well. Of course, some of it is theory. So I mean, some of it cannot avoid it, but don't be afraid of it. I mean, it is done in a way which takes care of a lot of this the problems that you think you would have. All right, so I think for today we are already I mean, we have overshoot the time by significant amount, and I mean, the session was very good, so we were all very engrossed. We didn't realize also that much, to be very honest. But again, the questions also now, most of it like is a little repetitive, and like the three questions that we've answered, actually it's like covered most of the stuff that people has asked. So that way, again, I mean, I think I mean, we are good to go, and we would maybe like to end the session. Let me see something. Okay. Sanjay, one last question, very
Yeah,
quickly,
yeah.
we'll answer this. Okay. Somebody has asked, are BFSI orgs using Copilot or Claude?
I think I have mostly seen Copilot, right? but maybe in some cases, yes, Claude, off late, people have you started using other alternatives as well, but I think Copilot is most common.
Right. Wonderful. I hope that answers your question. Okay. Then maybe, I mean, let's close the session for today. First and foremost, thank everyone for joining in, taking your time out and joining in. I hope you uh, enjoyed the session and I hope the session was informative. To Sanjay, once again, thank you so much for the very informative session. It's very useful for, I mean, I think, I hope the participants found it useful, but yeah, it was very informative. So, I mean, for the participants, as you all know, we do conduct this webinars regularly. I mean, I mean, month we have one or two webinars. I mean, in fact, actually this month we have another one coming up, which is on 30th. You can register for that as well, which is on evolution of credit risk and which is navigating the expected credit loss mandate in India. So people who are interested in risk management, that can also be a very informative session. It is so essentially, please feel free to register for that as well. See you in the next webinar, and of course keep track of our social media channels, websites, and we would also intimate you for the next webinars. See you in the next webinar. Thank you and good day.
Thanks all. Thanks for being good listener. Thanks.